Okay, now we're ready to go. So we are on. So I have the awful habit of sitting in front of my email all day long, right? It's terrible, terrible. It's an addiction, really. Okay, but that's good for you because I can respond to you usually very quickly. Okay, here's, so the most easiest is mark.a, but if you forget, it's just mark.ashbrook, okay, at asu.edu. So always do a little research before emailing me, but don't hesitate to email me. So oftentimes questions have already been answered. Look on Blackboard, look on the syllabus. Just do a little research first, but then please email me if you have questions, okay? I'll show you Blackboard. That's going to be our home base for the course. It's where the syllabus will be posted eventually. Written assignments, other course docs, exam results, grades, okay? I'll mention it now, I'll also mention in the future. Sometimes in the gradebook there's these overall and total entries, like it's trying to calculate your grade. Just ignore those, okay? I only use the Blackboard gradebook for individual scores, and then I download it all and crunch the numbers. So anytime it's trying to show you a grade in the class, just ignore that. If you want to come to my office and talk about your standing, I'm happy to do that. Okay, there's a pretest. This is a required element. It doesn't matter how under or overqualified you are to be in this course, okay? So you have a large window of time to take that next Tuesday, Wednesday, or Thursday, August 27th through 29th. So let's more details on that. Let me show you on Blackboard more details about that. On the Blackboard announcements, I tell you where and when, and the logistics, okay? So we'll see Blackboard in a second. Graphing software, graphing calculator. Okay, so this is a required element in the course, but it's, because I have connections, it will be free for you. Okay, so graphing calculator is not a handheld calculator. So it's an unfortunate name, okay? It's an unfortunate name because it's kind of confusing, but it's software for your computer that does everything your graphing calculator can do and 20 times more, and all of it 100 times better, okay? So it's going to be an essential element of this course. There'll be certain assignments where you're actually coming up with visualizations and you're doing mathematics using this and submitting. So it's a required element, okay? Again, but it's free for you. So if you have a laptop, which most of you do, that's where you want it because you're going to use it in class sometimes too. If you don't have a laptop, then whatever computer you use at home, you can put it on that as well. But laptop is first priority. Again, when we go to Blackboard, I'll explain more about that. So the online text and homework is my math lab, and that's the. Does anybody have the text? Yeah, just so we can hold it up. Yep, that's it. Okay, and so that comes with online access. The online access is the only thing you're going to need. Okay, so but if you like the hard copy, you also have that with you. So the online access to the text, we'll mostly be using it for the online homework system, but we'll really only be using that in the second half of the course. Okay, so I don't have the course set up yet, which is fine because we won't really need it until we get about a month or a month and a half in. Then we'll start using this extensively. Okay, so I'll give you more details later about that. So course ID coming soon. Okay, we'll use this very little in the first half of the course, much more in the second half. Okay, so let's go to Blackboard and many of these things we're going to talk about again. Okay, so Blackboard, here we go. Okay, so here's what you see when you come to Blackboard. And if you're enrolled in the course, you should have a link to this through my ASU. The first thing in the announcements is your tasks for Monday. Download the syllabus when it arrives. Okay, so you got a syllabus link over here on the left. Coming soon. So as soon as I get those test dates nailed down, I'll finish up the syllabus and get it for you. Download graphing calculator, instructions below. Complete the first homework assignment is in assignments. Okay, so you're gonna download module 1, section 1. You're not doing the whole thing. Hear me out. This is So we'll do the second half later, but you're only working pages 1 through 5. There's reading, there's reflection questions, and then there's some guided problems, okay? Don't go past page 5. That's, page 6 starts a new section. We'll do that later, okay? So it'll be like for next week. So only 1 through 5. Let me make this bigger, sorry. There we go. Okay? So, syllabus. So the graphing calculator. If you come down here in the announcements, there's all the instructions for downloading it for Mac and for Windows. Read carefully. You got the links. And then once you get to the point where you download it and it's all you want to open it and run it, then the window will pop up and it will ask you for that you paid for it, right? That you paid for it. Well, this is free. Okay, so you have this as your name and serial number.
Does it need does it only run on current Mac software?
Give it a try. If you run into difficulty, then we'll talk. Okay, but yeah, I'm not really sure. But here's your. This is actually trial version. This will expire halfway through the semester, and then those of you who are still around, I'll give you an individual copy again, free. Okay, so this will expire about halfway through the semester. And then I'll give you all your individual license codes, okay? Questions? And if someone can, a good multitasker, if you can, someone try this now. Maybe you're not probably the best one to do it now. But you just did it? And everything's up? And you were able to open it? Okay, and so when you open it, this is what you'll see. You should get a window like that. And then you know you have it. And everything's cool. So we have some success from some of you. So you want to do that. So that's that. First homework assignment we talked about, graphing calculator. Pretest, so we talked about the pretest. Again, required element. You take it next week, Tuesday, Wednesday, or Thursday. In PSA 21, that's the basement of PSA, and that's what's called the testing center. You've got a huge window of time here. Any one of those 3 days, enter between 10:30 and 6:30. Yeah, so you know how to write this down. It's all on Blackboard, okay? So this is on the announcements. So enter anytime between 10:30 and 6:30, and then you have till 8 to work. But my experience is the pretest. Most people take a half an hour to 45 minutes on this. Very few use more than an hour, okay? Don't bring a calculator for this. But we need a Sun card for the testing center. And not only is this required, but then I'll give you some extra credit on exam 1 depending on how you do. So try, okay? Do your best. And the better you do, the more bonus you can earn on exam 1. Okay, questions about the pretest. Next Tuesday through Thursday, I'll remind you again Monday. Yeah.
What are the topics on that?
It's pre-calculus stuff.
Okay.
Yeah, pre-calculus. Yes?
Yeah, is that a multiple choice question or short answer?
Multiple choice. Yep. Questions about downloading software, the pretest, or tasks for Monday? Yes, sir. Or ma'am. Sorry.
What's the format of the homework? Typed up or written?
Oh, you can write out. So separate sheets of paper. So your own separate sheets of paper, and then so you'll see it's kind of a mix of reading and reflections and questions. It's not like exercises in the book. You'll see. So just read carefully. Anytime there's a question it's asking you to answer, you've got your separate sheet of paper. You answer it. Okay. So don't miss any through there. So some of them might be a little bit hidden. But if you read carefully, it'll be easy to find them all, okay? So, yeah, always write up homework on separate sheet of paper, okay? And then some of it's going to be asking you for explanations and sentence and paragraph kinds of things, right? So use complete sentences, explain your thinking fully, okay? No one-word answers. Any other questions? Homework, pretest, graphing calculator, or the book, online book. So all that stuff's on the announcements. Okay, where are we here? Okay, so this is kind of fun. That's my 10-month-old baby girl, Emma. Oh. So you gotta look closely here at the shoes. You gotta have the shoes, right? Future baller. And so she's starting early. She's starting her. So this is from the summer, or May. This is from May. And that's about a week or two old. So that's a week or two ago we took that picture. Does she look like me? We adopted her. So she's our adopted little girl. So if you know about another potential adoption situation, talk to me, okay? So sometimes, people your age get into trouble, but you can make good out of it, right? Okay.
Oh, I see.
Okay, so if you know of a potential adoption situation, love to talk to you. All right. Also, need electric guitar player for my band. So if you know someone who plays electric guitar, talk to me also. All right. So we went through that stuff. So let's talk about this course. What I want to do is I want to take a good chunk of time in today's class to prepare you for what's going to be a very different feeling math class than many of you had in the past. Okay, so we're going to take a lot of time to talk about the kind of the hows and the whys about all this, so that you know in advance. Be ready for something really different. Okay. So I want to talk about the context with the reason for this, math education in the U.S. and other countries, and what calculus is and how we develop it. So natural science and engineering degrees per 120, so it's a percent of 20, 40-year-olds who have a natural science or engineering degree. This is in 1975. So you see this there with a third from the bottom. How are we doing here in 1975? Second or third? Doing pretty good, right? How about in 2000?
What?
How about in the year 2000? Third to last, okay? Third to last. So, when you're at a party here in the U.S. versus a party in Taiwan, how acceptable is it to talk about being an engineering or math major or a science major? So, it's probably in Thailand, Finland, but here in the United States, it's kind of like there's this stigma, like you're a nerd if you like math. So that these attitudes, compound and snowball, and our performance goes down over time. Okay, any company that hires you is going to compete with students, with other countries. We have instant travel, and we can even do a job overseas just by sitting in our own bedroom, right? So now it's a global market, and so any company that hires you is going to be competing with other countries. Okay, so there was a video study that taped 100 randomly selected 8th grade classrooms in Germany, Japan, and the U.S. And they did a very good job of transcribing the videotape lessons, taking away all the cultural identifiers. So people reading the transcripts had no idea which country that particular classroom was in. And so then they rated the quality instruction in each country, Germany, Japan, and US, high. So what percent of the time was it high quality instruction, and what percent medium, what percent low? Okay, based on these transcripts that had no indicators of country. Okay, so Germany was about a third each. So a third of the time in the German classroom was high, a third of the time was medium, and a third of the time was low. In Japan, better. At least half the time medium and only 10% low. Okay, so what do you think this study found about math education in the U.S.? What percent high and what percent low quality instruction?
Maybe 10% high, 20% low, or 20% medium, and the rest low.
Okay, so he's saying 10, 20, 70. Yeah? Yeah? That's a smart man right there. 0% high quality instruction, 89% low quality instruction. So let's talk about what do you think that is? When they say high quality instruction, when they say low quality instruction, what specifically are we talking about? So now we're talking about in the classroom, right? So the classroom and the course.
How you try to captivate the students, make them actually listen to what you're trying to
Okay,
say.
attention level. Okay, what else do you think incorporates low versus high quality instruction?
Student comprehension.
Okay, so specific things that we're doing in the U.S. math classroom. That's that. Yeah.
Student understanding of significance of the idea.
Okay, so yes, exactly. All those things are true, but this is what this is talking about is specific ways of teaching. So what are the methods and ways of teaching that are considered low quality or high quality?
I would say probably lecturing and problematic approach as opposed to the idea behind mathematical concepts.
Okay, yeah, now we're getting on the, yeah.
I think like when they try to like take the problem out of the book and just do it on the board and then just kind of guide you through it, like just like kind of like a cookbook type.
Okay, so now we're getting on the track here.
Kind of the opposite. More the teacher actually makes the student kind of learn the whole, like they just shove the whole book in front of you saying learn the lesson yourself, and then there's some problems just to help you out, that type of thing.
Okay,
How will they teach application?
okay, so low quality instruction would be what relative to application?
You know, teaching
Okay.
them how to apply it.
Right, okay. Yeah, so we're really talking about a high degree of low quality instruction means a very strong emphasis on like procedural mathematics, meaning teacher gives some definitions, does several examples, teaches the students to mimic those examples, mimic the steps. Anyone have this experience in a previous math class? More than half of you, right? Okay? And so that's what they're calling low quality instruction. And then a lot of you are talking about understanding the ideas. So that doesn't happen. That doesn't happen. All you learn is how to do step 1, step 2, kind of learning the rules. You're learning the rules, and there's no real understanding of the underlying mathematics. Okay? That's what high is about. Students coming to a point where they're able to actually converse around a problem because they understand what's going on. They understand, what the ideas are and how it fits together, rather than just step 1, step 2, step 3, step 4. Yes, sir.
Anybody have fault for that?
So this is a systemic problem. It's a cultural problem. It's over decades has become ingrained in our system. And so now it's become this culture in the math classroom. What do you do in math class? Well, show me how to do the problems, and show me some of the exceptions to the rules and the tricks, and then the students replicate those. It's just become a culture. It's become just a embedded cultural thing. So, what is calculus? Is it just a bunch of complicated procedures? All right, if you guys know about this, Wolfram Alpha.
Yeah, that got me through my math class.
Yeah, it gets you through, right? Why? Because all these things that were being taught in these math classes, all these procedures, it can do with a click of a button. And it can do it a lot faster, obviously, more efficiently, and 100% accurately. Okay, so if you put in what is the integral of sine x cosine x dx from 0 to pi over 2, that's a calculus question for those of you who've had it. It gives you the symbolic notation, it gives you a graph, it gives you equation, and then more if you want. So just by clicking a button, it solves the whole problem and gives you all these different things. All right, the graphing calculator software that you're going to use. So here's another calculus problem, the derivative of x to the 3 to the x. It's a really difficult derivative. That takes a pretty complicated procedure to get it. Click of a button, graphing calculator can do it. Just tells you the answer. And we might spend a whole class getting up to being able to do a problem like this, mechanically or with the symbols, just moving the symbols around. Graphing calculator can do it in an instant. Okay, so we want to use these resources. We want to be honest with the situation that we're in. We've got awesome technology that can do all these algebraic things like that. Okay, so it kind of, in our day and age, it's not really making sense anymore to spend hour after hour learning these procedures, right? So then what So, but historically, that's what we needed. We didn't have the technology, and to get a job, you needed to do these procedures, all this computing quickly and accurately. Okay. People, to get a job, you need to be super fast at performing procedures flawlessly. Okay, so they were given calculus, users of calculus were given functions and equations. Their job was to do with them what they were told. Okay? But today, we've got computers, we've got technology. We can do it far more quickly and accurately than a human. But what can computers not do? They can't decide what function to analyze, what equation to solve. So calculus today is more about being a manager. Okay? So in a restaurant, who has more knowledge of the store? The waitress or the manager? The manager has to know everything, right? The manager has to know what the bartenders do, what the cooks do, what the waiters do, what the maitre d' does, okay? They have to know how this whole system works and fits together to have a successful restaurant. And that's what it's like coming to calculus. It's about knowing all the pieces and how they fit together and being able to manage that to solve problems. So we need to understand what we're doing and be able to explain why we're doing it. So these are what students in these countries, Taiwan, Finland, the ones at the top, students, this is what students are able to do that we're failing here in the US. We're failing. So, what's your past experience? You reflect honestly. When you worked with symbols, performed computation, to what extent did you understand what it represented? So just think to yourself. Did you understand what was going on, or were you just taught to move these symbols around? So be honest. Okay, so what's this class about? We want to develop a real knowledge of calculus so that you can problem solve, so you can figure things out, not just remember what I was supposed to do. So, oh, when I see that symbol, I'm supposed to do this. But we want to be able to take a new situation and be able to make progress at solving it. Okay? So if you've had calculus before, or something seems, or even lots of ideas in pre-calculus, if it seems familiar, pretend it isn't. Kind of start over. Okay? Try learning it with understanding, learn it with meaning. So try to come with me so that there'll be this temptation to kind of say, oh, I know how to do that, done it before, so I can kind of tune out. All right? Don't do that. So pretend you've never seen it before and really work for a deeper understanding that I'm trying to pass on. Okay, so the moral is that good math instruction in US, not good internationally. Okay, and so I'm warning, okay, warning. This class is going to be different. Don't expect this class to reflect your experience in the past. You've all taken many math classes. You're coming in with a set of expectations. And so when expectations don't get met, there's frustration, right? There's frustration, okay? So I'm trying to warn you, So here are these things of low quality instruction. Rote memorization, replicating examples and procedures, just doing without thinking to get answers, focusing, I gotta get the answer, Or guessing when I ask you a question, guessing what I want you to say. All right? What it is about, developing your ability to think, okay? So you can understand the ideas of calculus. Develop insight into the world of quantities and relationship among them. This is the whole ballgame with calculus. How quantities change together. That's what the study of calculus is. We've got all kinds of quantities in the world, and they change together, and that's what calculus models. Okay, ideas will come in groups. It's not going to be section 1, master these exercises. Now we move on to section 2, master these exercises. Then section 3, as like disjoint kind of types of problems. Everything builds on itself and has coherence to what we've done before. All right, and then we have a large goal for the whole course. This is an endeavor for coherence of all the ideas, and that's called the fundamental theorem of calculus. Okay, so that's 80% of what we do in the course is going to be about building an understanding of this. So we have to take some alleys there to learn some things that are not quite related, but the primary focus of the course is coming to a deep understanding of the fundamental theorem. Okay, so when I ask a question, it's going to be, or when you're doing homework, it's going to be based on your understanding. Okay, not replicating steps or procedure. Okay, bringing together ideas, transferring knowledge, and then being able to write and speak what it is you understand. Okay, if you're having difficulty, so many of you, there's all kinds of tutors all over campus. You sit down with them and you put a problem before them, and they'll just take your paper and then they'll do the problem. This doesn't help you at all. This doesn't help you at all. Okay, that's a little exaggerating, but that's what a lot of tutors will do. They just kind of, here, I'll show you how to do it, and that doesn't really help you. So when you come for me for help, this may be a little uncomfortable at first, but I'm going to ask you questions. I'm going to find out what you understand and start bridging the gap and making you think along the way. Okay. All right. So occasionally I check. What is it? I always forget. RateMyProfessors.com. Okay. Occasionally I check that, and probably many of you have too. All right. So here's student number 1. Tale of two students. He's honestly a terrible teacher. Nice person, but tries to teach the why and forgets about the how. It really kills your grade. I've never had below a 95, and now I'm hoping to get an 88. Okay, so these words, terrible, horrible, awful. These are, this is like a cue to me that this student came in with expectations. They came in with expectations of what this math class should be like, and when those expectations didn't get met, he was disappointed. Okay? To this student, what's a good teacher? Probably. So we can't be sure, but probably. What is a good math teacher to the student?
Just gonna probably be someone who shows the steps over and just kind of more repetitive type of thing.
Demonstrates, he nailed it on the head. Demonstrates and explains complicated procedures really well and assigns grades based on ability to mimic them. Okay? So if that's your expectation, and you're not willing to work at changing that, we're gonna butt heads, and it's gonna be rough, and then you're gonna do this to me. You're gonna put one of these up, okay? Okay, but what is this instruction? This is the kind of instruction that's putting US at the bottom internationally. You see? So we're trying to do something different to improve. Student 2. This is actually an email that she sent to me. She said, for the first 4 weeks of class, I left every day feeling that my brain had been mauled into abstract obscurity. Now I was actually helping my friend from another college with her Calc 1 homework. She was amazed at how much I knew. And even though all of our language was different, I was able to, and it's not all of our language, a little bit different, okay? I was able to teach her why each piece works and what it's there for. I've also been helping people at my table from class with the homework. It is so satisfying to be having these daily aha moments. Okay? So you see that it took some time for her to start making the transition in her own attitude. But if you work at it, then you can. Okay? Okay, and so this thing about it hurts your grades. So here's results from 2 semesters ago. Last semester was very similar. So 69 students finished my course 2 semesters ago. Here was the breakdown. Very, very similar to other Calc 1 courses on campus. Okay? And it's really about your desire and your willingness to work outside of class. Okay? I'm going to post videos, and I'm available in office hours. We'll also have a TA who can help you. You're going to need, it's not just going to be this instantaneous, oh, I get it, and everything's rosy, and I'm going to get an A in the test. You've got to work outside of class. You've got to really work on it outside of class. Okay, any questions about that? Fairly warned. So that this is the whole point of taking all that time, was to say it's going to be different. It's going to be really different, and uncomfortable, for sure. Uncomfortable. You're going to discover these attitudes that you have in yourself because of years and years and years of math being a certain way. Okay, but our goal is a real, true understanding of calculus. All right. So, moral of the story: meaningful learning requires hard work. It's going to take patience, perseverance, and time, okay? But the benefits are great. Okay, so let's talk about calculus. Just give a little overview before we dive in. So what is it about? So there's two fundamental problems that calculus addresses. The first is, you know how much of something there is, and you want to know how fast it's changing. So we're talking about a quantity here. So we have some quantity of something. So the first question is, we have that quantity, and what we want to know is, how fast is the quantity changing? At what rate is it changing? Okay? And then the other is kind of the flip side. We know how fast a quantity is changing, and we want to know how much of it there is, or how much total change we have. This is really all calculus boils down to these two questions, which are really just two sides of the same coin. Okay, the first one is differential calculus. Some of you have done derivatives, okay? So that's what that first question is. It's a matter of differential calculus, and then the second one, integral calculus. You know how fast something's changing, and you want to know the amount, the quantity, or the change in the quantity. So like we said, there's really two sides of the same coin. You know how much of something there is. Those changes accumulate, and we're asking at what rate they accumulate. Everything that accumulates, it builds up bit by bit, okay? And so it's really this cycle, and the whole thing is about rate of change. How fast is a quantity accumulating or receding? How fast is a quantity accumulating or receding? Okay, so let's just, how were we at here? Oh, we got 10 minutes left, perfect. So just to give you a little prep for your assignment, so the assignment you could pretty much do without anything, because it's a lot of reading and guided practice, but we'll do this anyway. Okay, so again, quantities, how they change, the rate of change of quantities. So let's just start with a little bit about quantities. So suppose that instructions on the drink mix say that 12 tablespoons of powder should be mixed with 50 ounces of water. Okay, so we want a good tasting drink according to what they're instructing us. They say you're going to need 12 tablespoons for 50 ounces. Okay, so we want to have a visual way to model this situation. This is probably something you've not seen before, but we can use bars, horizontal bars. The length represents the value of a quantity. So how can I use these bars to represent that first initial situation? How can we use the bars to represent that situation? I'm going to have I don't have it today, but I'm going to have a roster and be calling you by name. Yes, sir?
I want to share, are these bars like the exact lengths or so?
What's that?
Are these like the long bar we represent as the 50 and the small bar we represent?
Okay, so yeah, so the long bar could be the number of ounces of water. And then what is the length of that bar?
That would be 50 then?
50, right? And then what is my writing will get better, trust me. What is the length of the short bar represent then?
That would be the 12 tablespoons of powder.
Number of tablespoons. Somebody else, what's the length of that bar? 12. So do you see how this represents the situation that I gave you? It's a visual way to see that and represent that. Okay. So how many ounces of water should be mixed with 4 tablespoons of mix to achieve the right taste? How many ounces of water should be mixed with 4 tablespoons of mix to achieve the right taste? How many people, when they saw that question, immediately thought this? Do this. And then AD equals BC. Did that instantly go through some of your minds, right? This is what you're taught to do, proportionality. Set up the proportions, cross-multiply, and done. So we're not going to do that. We're going to think through this. We're going to reason through this. So how can we want to use the bars to kind of illustrate what's going on here? Yes, ma'am.
Since 4 is 1/3 of 12.
Okay, let me stop you right there. 4 is 1/3 of 12. So how can I represent that on the bar? What can I do?
2/3 of it.
What's that?
Make it only 1/3 of the length.
Okay, so right about here is about 1/3 the length. So that length right there would be 4. So I could break that bar into thirds. Keep going.
Then you'll want to do the same thing to the bar that's 50 units in length as well. So you want to break that into thirds as well.
Right, so if 4 is 1/3 of 12, then we want what? 1/3 of 50. Do you see the vast difference between reasoning like that and just plugging into the fractions and cross multiplying? Do you see? So that's all about reasoning. That's all about what's going on. And so what do we want? So this right here, the amount of water is going to be 1/3 of 50 because 4 was 1/3 of 12. How do we calculate 1/3 of 50? What do we do? So you can divide by 3 or multiply by 1/3, right? So 1/3 times 50 or 50 over 3. And that's ounces. So that's just an example of how you can think about a problem in a conceptual way versus in a mechanical way. But this is also the starting point for all of calculus, is really understanding two quantities, right? Two quantities taken together. Okay, so same thing, same 12 tablespoons, 50 ounces of water. So now I want to use the bars to illustrate how much powder would we require for 180 ounces of water. So this is a little one step more difficult, okay? So we got to think about this. So what I want you to do is briefly introduce yourself to the person next to you. Maybe talk about what you did this summer for about 10 seconds. And then talk about how would you use these bars to talk about this situation. We want to know how much powder for 180 ounces of water. Go. This one's different. You gotta set it up differently, right? You gotta set this up differently. Okay, so we'll start with the same assumption, but from here on. So let me ask here. How about in the green shirt here? What's your name? Pat. Did you get started on this?
Yeah.
What's that?
Didn't figure it out.
Didn't figure it out. Nice. So just, what did you do first? What did you do first?
I drew 3 more of those bars.
Okay, so, and that's problematic because it's going to put me in the hallway.
No, I just replicated the same bars.
Okay, all right. So you put them down below. Okay, that's good. So you started and you made this bar be how much? 50. But then you needed to reproduce this drag 3 times. Okay, that's okay. Anybody do it a different way?
we kind of took it all, we went over the 180 to get it to an even 200 and then just decided to like how much of the.
So what did you call the length of this bar? Still made it 50.
Yeah, we just made 4 bars in total.
Right, so that's kind of similar to what he did. Yeah.
You could make the top bar 200 and the bottom bar would be 48.
Okay. 248. Okay, so he wants to make this 248. These are all possible ways to do it. Okay? Yeah.
I basically turn that whole long term to 180, and then I figured out then how many times does it take for 50 to get into the 180?
Okay, so if this one's 180, then how long's that?
That would be then what I did was then I just kind of figured out how many times 50 went to 180, and then I multiplied that by 12.
Okay, so it's the answer to the question, right? If we call the long bar, that's what you're saying. You're kind of talking me through it. That's good. But if we call the long bar 180, then this bar then is now the answer to the question. You see how this is different than the last one? So this prevents us from having to extend this bar, like I said, into the hallway or draw lots more, which is perfectly good. It's good reasoning. But let's do it 180. And so then, where do we go from there? Let somebody in. Yes, sir.
Going off of what he said, you have to find out how many times 50 goes into 180. I figured out that it goes into it 3 3/5 time.
So maybe 50 is right here. And so there's another 50, or sorry, 100. Is it there? And then, what would that be? 150. So what's that part of the bar right there? It'd be right. It'd be 3/5 of 50. Yes, it's 30, right? So this is 30, and 30 is 3/5 of 50. So then how can we use that reasoning then to figure out how many tablespoons of powder?
If you multiplied 50 times 3 3/5 to get 180, you would multiply 12 times 3 3/5 to get your number.
Right, so 50 then corresponds to? 50 corresponds to 12. And so if we had 3 3/5 of 50 ounces, then we also need 3 3/5 of 12 ounces. There are other ways to do this, okay? So there's other ways. But that's a nice way. And how do we calculate 3 3/5 of 12? How do we get that number? Multiply. Okay, so what we're seeing in these problems, and who got an answer? Notice how I just stopped and I didn't want to even do the answer. So that's another thing that's different. Like maybe in the past there's been a real focus on getting the right answer, right? We're going to be focused on the process, understanding the process, because if you understand the process, answers are a piece of cake, right? Answers are a piece of cake. So anyone get a number? 43.2 tablespoons. What was I going to say? So, so what we're noticing here about comparing these quantities, it's a lot to do with multiplication and division. So that's really how we're going to start the course. Is we're going to take a step back and ask, what is multiplication all about, and what is division all about? And you'll see that in the reading, and we'll talk about it on Monday. So, you got your checklist on Blackboard announcements. First assignment due Monday.